Hi, this is a quick tutorial about ANSYS Fluent workbench and design modeler. So in this one, we will look at a flow, laminar flow basically in a pipe. To start with, we'll click on Fluent. So let's say double click, and this pipe will be simple geometry, so we can make it a axisymmetric 2D model. So go to properties, select 2D, close it. Then double click on geometry or right click, and then it will open a design modeler. Now you have to create a sketch in XY plane. Right click XY plane, and if you click on this graphics and say look at, so it will open it drawing at XY plane. Click on Y here, so that you can see ZX plane. Click on X, the YZ plane. So basically we need to see XY plane, so click on Z, XY plane. Now go to sketching and select rectangle, create any rectangle, go to dimensions, and using general dimensions, create dimensions. Select the dimensions as 10 meter length and 0.15 meters as width. Now we have to create a surface from sketch. Select that, and then you have to select which objects you are going to select. So box select this, say apply. Thickness will be, let's say, 0.1 meter, and generate. So here you can see it generates a surface, basically this one. Okay, now we're done with geometry, so let's save it. And you can basically close the geometry. Now we come to the mesh and double click on mesh, so it will open meshing. So once it is open, first thing we'll do is we'll just create a default mesh. So default mesh can be created by selecting mesh and then right click on it, generate mesh. Now you can see the mesh is generated. Other way to do this, go to mesh and generate mesh, same thing. Since we want to create our own custom mesh, so here you see that mesh is not pretty much regular, so we want to make our own custom mesh, and for that we'll go to mesh control and map face meshing. Select this and say apply, so it has applied. Now we'll create a edge sizing. So basically how many cells will be there in each edge. So first we select edge, and let's select first edge and second edge, and go to mesh control and sizing. Okay, element size. So we'll keep number of elements as 100, and we can see the 100 elements are there. Okay, to create our own custom mesh, we'll go to mesh control and sizing. Once it opens up, we'll select edge and then top and bottom edges of the rectangle and say apply, and then go to type and say number of divisions, and we'll divide it into 100 divisions. Say okay. Similarly, we'll go to inlet and outlet edge. Sorry, before that we'll go and create another edge. So we'll go to mesh control and say sizing. So we open up another sizing and we select this and this edges, say apply. So you can see two edges are selected. Now go to type and say number of divisions, and we divide it into 10 divisions. Enter. Okay. After that we'll go and either update or click on mesh and say generate mesh. So now it will generate a custom mesh for us. Now we'll check our mesh sizing by going to statistics, and here we see the number of elements are 1140. What we'll do is we go to edge sizing and change the behavior from soft to hard, and similarly we'll go to this edge sizing and change behavior from soft to hard. Once we do that, go to mesh and let's say generate mesh. Now you can see that the meshes are pretty much regular. Now we will create names for the edges. So first we will go and select edge, select this edge and right click and go to create name selections, and let's give a name as inlet. Top one, right click and say wall, or let's say 5 wall. Bottom one will be center line, and zoom in, and the last one will be outlet. So now we are done with geometry, and let's close it. Before that we would like to go and see statistics. You can see the number of elements as 1000. So let's close this. Now you can see in the mesh, this shows that you have to update it. So just right click on it and say update. So green check will show that it is updated. Okay. Double click on setup and this should open Fluent. Go to double precision and select OK. So this will open up Fluent. So we'll go to general and select pressure based, steady state, axis symmetric, and then we go to models, select viscous laminar, which is already selected, and say edit. Here you see it is already laminar. Say OK. Then we go to materials, and in this case create and edit. So let's give a density of 1 kg per meter cube for air and viscosity as 0.002. Create change. Close this. Now we'll specify boundary conditions. So go to boundary condition and start from center line. So here you can see this is showing as wall, but it should be axis. Okay. Go to inlet, velocity inlet, edit, and velocity magnitude should be 1 meter per second. Say OK. Interior surface body is interior. That's okay. Outlet should be pressure outlet. Go to edit, and here you can see 1 bar. Okay. Pipe wall should be wall. So that's all right. Stationary wall and no slip. Okay. Then we go to reference values. We can show where it should compute from. So let's say tell it from inlet, and everything else is fine. Go to solution methods and specify second order of wind. Then we go to solution control, which is okay, and monitors. So edit, and error should be, let's say, 1e minus 6 for each one of them. And number of iterations is 1000 is okay. We go to solution initializer and compute from inlet, and let's give an Excel velocity inlet as 1, that's okay. And go to run calculations, number of iterations specify as say 100 and say calculate. So it says that solution should be initialized. So we go to solution initialization and say from inlet, Excel velocity should be okay, and say initialize. Go to run calculation, calculate. So should calculate, and solution is converged here, you can see. So basically it converges, and we go to graphics and select vectors and set up. Velocity over center line, so here you can see. In order to see the whole pipe, first we'll select vectors and go to display and select views. Say mirror plane is center line, apply. So you should see that the whole pipe is visible now. Now we go to vectors and we'll select velocity, velocity magnitude, and it should be interior surface body. When you say display, it can display you the whole result. Maybe you can try to see the inlet region. Yes, sorry. Select this one. Again, select, and here we can see that how the velocity is converging. If you want to see a better view, put the scale to, let's say, 0.5 and display, so it shows a little better picture. Now close this and go to graphs or plots, XY plot, double click on it, and let X be 1, Y 0, and select velocity and axial velocity from center line and say plot. Here you can see that initially velocity at the center line is 0, and then grows and it starts with 1 and grows to almost 2 meters per second. If you want to save this, you can just go to write to files and say write. It will ask you to save, just say velocity.xy and save. And you can similarly go to density, properties, wall fluxes. Let's say you want to select wall shear stress, go to wall flux and select wall shear stress or skin friction coefficient. Close to pipe wall, and then it should plot the skin friction coefficient. Thank you for watching.